In today's lesson, we're going to learn about subtracting integers. We're going to start by watching the Math Club explain subtraction of integers.
Subtraction is everywhere, all around us. You can see it when you buy 5 more lives on Candy Crush for $1. It is the world that has been pulled over your eyes. You take the blue gift card. The story ends. You're back in elementary school, subtracting lines on a chalkboard. You take the red gift card. And we see how deep this hole can go.
Up until this moment, you probably believed subtraction was a fact of life.
You'd believe that if you spent $1 on a book on jiu-jitsu and then paid the clerk $10, you get $9 back.
Nope. Subtraction isn't real. 10 minus 1 is the same thing as 10 plus negative 1.
Subtracting a signed number is the same thing as adding its opposite, or additive inverse.
Subtraction doesn't exist.
Subtraction doesn't exist.
The matrix has been revealed.
Heads up. For your entire math career, it has been hands off the operation. Well, guess what? Now you can change the operation from subtraction to addition just by changing the sign after the operation. Crazy, right? This is an example of a minus b equals a plus negative b. This is one of the big moments I remember in math.
Addition and subtraction exist as two sides of the same coin. They're anywhere positive and negative forces collide. Good and bad feelings, national politics, and even right here in Gotham. Gotham was once a good city. There were positive people, like Alfred. Add a positive number, move in the positive direction. But over time, Gotham was corrupted by criminals. Add a negative number, move in a negative direction. But then, Batman came.
Hey, Math Club.
And he started cleaning up all the criminals. Notice that subtracting the negatives and adding a positive did the same thing. They both moved it in the positive direction, making Gotham safer. But then, the Joker came and kidnapped Rachel Dawes and Harvey Dent, and turned Harvey Dent into Two-Face. Adding a negative and subtracting a positive both moved Gotham in the negative direction towards chaos. But at the last minute, Batman captured the Joker, saved the hostages, and rounded up the thugs. In case you're wondering, I'm not going to do the plot for Dark Knight Rises because that movie was too crazy.
The great Mr. Math Club. We meet at last.
Wait. I'm negative. Subtracting a negative should make things more negative. I bet that you can't think of one example that 2 negatives make a positive.
Really?
Well, I don't not like him.
Chica, that means you like him.
Holy double negatives, Batman. 2 negatives makes a positive.
Busted. Our work is done here. Quick, to the Nebuchadnezzar.
Sometimes the matrix forces you to add or subtract long strings of numbers for homework. Even if you understand this concept, it can be really hard to see through the matrix. See if this helps. Draw circles around all the operations and the numbers that come after it. See any circles with 2 negative signs? Make it a positive. This is one case where 2 wrongs do make a right. Next, put plus signs in between all of the circles if they aren't there already. Lastly, add them all up. Remember, positive numbers move you in the positive direction, and negative numbers move you in the negative direction. This tip is a beta, so let us know if it's helpful or not.
Think you can handle the matrix? Head on over to the quiz to see what you've learned. Or unlearned.
Have a story where positive and negative forces collide? Make one up and put it in the comment section. We'd love to read it.
And remember what you learned. Subtraction is a lie. Subtraction is a lie.
1/3 minus negative 16 23rds. That is the sound of inevitability.
71 over 69.
Negative 6 minus negative 7.
Negative 13.
27 minus negative 64.
91. 42 minus...
So let's write down the rules. Basically, it's just the first bullet point there. To subtract an integer, add its opposite. So change the subtraction sign, the operation of subtraction to addition, and the number that comes right after it also gets changed to its opposite. Now that we don't do anything to the first number. And then the second bullet point is just our addition rules from yesterday, which should already be written in your notebook, but I've condensed them. If the signs are the same after you've rewritten your subtraction as an addition problem, you simply add the absolute values and keep the sign. If the signs are different, you will subtract them. You will find their difference. But you'll keep the sign of the integer with the highest absolute value. All right, let's take a look at this first problem. Negative 56 minus negative 9. We have to change that subtraction sign, the operation sign, to addition, and we're going to add the opposite of negative 9. Okay? So we rewrite the problem as negative 56 plus 9. Now, one thing you guys might do also, let me get this into a red color here, is in showing your work, is show that you've changed that to a plus sign, so that you can change this to a plus sign. And that's where, if you were in Mrs. Schwapik's class last year, she talked about the boom booms, because whenever you change subtraction to addition, you always have a second boom. You always have to change something else, okay? So in this case, you also, sometimes I look at it and I look at these two, that double negative, right? That's where the two negatives make a positive. That's what they were talking about with two negatives make it positive. Okay, so when you see minus a negative, you rewrite it. Now we have an integer addition problem. Let's look at the rules from integer addition. We have a negative and a positive. They're unlike, so we will find the difference by taking 9 from 56, and then our answer will be negative because the 56 is the higher absolute value. So we say that we're adding them, which we are, but because of it being integer addition, we're finding their difference and keeping it negative. So negative 47 is the sum. Okay, so it's going to be really important that you show your work of changing the sign. So you may want to do the, the boom booms in showing your work, but it's also a good idea to rewrite it as an addition problem. Let's try another one. Negative 14 minus 21. So since this is subtraction, right, we're subtracting two integers, we have a negative integer and we're subtracting a positive integer. We have to change the operation to addition. So we're going to add the opposite of 21. So negative 14 minus 21 becomes negative 14 plus a negative. And when we talk about the boom boom, the two things that we have to do is change this to addition, right, and change that to negative. So there's always going to be two marks you're going to make. You're going to change to addition and then change to the opposite. Whatever the sign was, you change it. So you either change it from a positive to a negative, or like up here, if it was negative, you change it to a positive. Now look at it. We have a negative 14 plus a negative 21. We have like signs. We will add them together. 14 plus 21, because we're going to keep the sign. And we get negative 35. All right, this time we're going to evaluate 15 minus A minus B when A is 24 and B is negative 36. So if it's a variable expression, we know the first thing we'll do is substitute in. So we're going to substitute 24 for A, and we'll substitute a negative 36 for B. So 15 minus A minus B will be 15 minus 24 minus that negative 36. So we have two subtractions to change to addition. So 15 minus 24 would be plus a negative 24. then minus a negative 36 would be plus a positive 36. So we could rewrite it as 15 plus negative 24 plus 36, and then we could follow the rules that we did yesterday where we will combine the like terms or group the forces together. So I would rather use commutative property and move the 15 and the 36 close to each other so that I could do 36 plus 15, and then have a positive 51 plus a negative 24, unlike signs, so I'm going to subtract the 24 or find their difference. And then I'm going to look and see which one had the higher absolute value, and it was my positive integer, so the sum would then be a positive 27. And you could work left to right as well and find the difference of 15 and 24, which would be a negative integer, and then do that with the 36. But in the end, you'll get the same answer, 27. I like to group my forces together. At this step right here, I like to find the positives and add them all together and then deal with the negatives. All right, here's some to practice. Go ahead and work on this, and then we'll check our answer. We're adding the opposite of 41, so we've rewritten to our addition problem, and we should get a negative 26. Let's try this one. Let's check our work. We're going to add the opposite of 8, so negative 16 plus negative 8. Like signs means we will add the absolute values and keep the sign. Negative 24. All right, one more practice. Let's use substitution when we're going to take a minus b minus a negative 6 if a is 8 and b is negative 15. We'll use substitution to substitute for a and b. So substitute 8 for a and negative 15 for b. Then change all. I see an error. Does anyone see an error? All right, there we go. We fixed the error. This was a textbook company created PowerPoint that I was borrowing. And so now we have 8 minus a negative 15 minus that negative 6 as copied in the original problem. So if we change all subtraction signs to addition and add the opposite of the next number, we're adding the opposite of negative 15 and the opposite of negative 6. We could simplify it with 8 plus 15 plus 6. The rules of integer addition, they're all the same sign. We just add them together and keep the positive number, the positive sign for 29.